tends to be some sort of counting number in these challenges, and here it is. So we've got a diagram and we're asked how many squares of any size are there whose entries add up to an even total. So we could use a square that's 2 by 2, could even use like a 1 by 1 square, or we could use like 3 by 3, 4 by 4, or in 5 by 5. Now, what you definitely don't want to avoid doing is adding up all of these totals. There's no way that you want to add up all of those 25 numbers. Actually, it wouldn't be too bad, but if you start adding up these four, for example, then it's just going to take a lot of time. So there must be a quick way to do it. And there is, because what we can actually look at is the remainder when we divide through by 2. Because when we then add up the remainders, we'll be left with it. Let me give you an example actually. So if I did 1 plus 2 plus 6 plus 7, of course I could add these up and divide by 2. But instead I can think about what happens when I divide by 2. Well, I'm going to get a remainder of 1 here. I'm going to get a remainder of 0 when I divide 2 by 2, a remainder of 0 when I divide 6 by 2, and a remainder of 1 when I divide 7 by 2. If I add up these remainders, then I'm going to get 2. So actually, when I divide by 2, that's going to become a remainder of 0. The two remainder of 1s kind of cancel out. So that is a possible first answer. That will be divisible by 2. And so what I can do is simply replace all of the odd numbers in my grid by 1, and then all of my even numbers by 0, because this is the remainder when dividing by 2. This is quite often a good technique for these sorts of questions where we're actually looking at the parity, that's what it's called, whether it's odd or even. And it's almost disguised that we've got all these other numbers. It just makes it more complicated, so we try and make it more simple. Okay, and now I'm going to systematically work through the different possibilities. So for the 5 by 5 grid, it's very easy now to see that I've got 3 rows with 3 ones in. That's going to take me up to 9. And then 2 rows with 2 ones in, which is 4. So I'm going to get 13 overall. And that means it's not possible to add up the entries in the 5 by 5 grid to give an even total. It's going to be odd. Let's look at 4 by 4. Okay, so now when I draw it, I'm going to have 2 ones in every single row. I'm clearly going to get 8 for this one, but as I shift it along, I'm also going to get 2 ones. And there's going to be 4 grids in total that I'm just outlining here. And so there's going to be, that's it, there's 4 by 4 squares. Done. 3 by 3. Okay, now there's two different types of 3 by 3 squares that we can get. We could either get this one, and then you see that the numbers are going to add up to 5, so that's not going to be an even total. Remainder of 5, when we're dividing by 2, is going to lead to a remainder of 1. Because when I'm calling it a remainder, I don't quite mean remainder. I mean like I'm talking about the remainder at this point when I'm dividing by 2, but then I'm adding them up, and basically if it's odd, the remainder is going to be 1, and if it's even, the remainder is going to be 0. I'm just using the word remainder throughout. Okay, so that one isn't going to work, but if I go along to here, then I've got 4 ones, and that will necessarily give me an even number. Okay, but that's the only one if I draw a square in the top 3 rows. If I then come down, then that is going to work, and that one's going to work. So I've got 2 squares if I go for the second to fourth rows. And then finally, if I go with the third to fifth, I've got another possible square. So it's going to be another 4 grids with 3 by 3. 2 by 2. Actually, every 2 by 2 grid is going to work. So I'm going to have 1, 2, 3, 4. And that was when I was using the top row. If I use the second row, I'll get another 4. Third row, another 4. Fourth row, another 4. So it's going to be 4 times 4, 16. Okay, you can, if you want to be a bit more careful, you can sort of imagine drawing boxes all the way around and see that it works. Finally, we are allowed 1 by 1 squares, and we've got 25 numbers in total. 24 numbers if we go like, then we've got an odd followed by an even, odd followed by an even. So I just need to do 24 divided by 2, all the even numbers up to 24, and that's going to give me 12. And that is it. So how many squares in total? Just need to add these up. 4 plus 16 gives 20. 4 plus 12 gives 16. Add these two together, 36 grids. Fantastic question.